Hey everybody, so welcome to virtual learning. So I'm going to start by going over your homework that we assigned on Friday. I am just going to post these. They are all worked out. So you can kind of, if you need to pause the video and like check through the work, see what they were doing. I'm going to do brief explanations on each one. If you need to go back and re-listen, please. I mean, like that's going to be a common theme here. If you need to rewind, re-listen, do that. Make sure you catch everything. So on 41, what they did is they essentially would have written this out twice and foiled it out. If you foil it, this is what you're going to get. And then they chose to basically group the sine squared and the cosine squared because we know that's a Pythagorean identity. So sine squared plus cosine squared, they just moved next to each other and then turned that into 1. And that was it. 43, they got a common denominator. You would need one of each of them. You'd have to multiply this one by 1 minus cosine, this one by 1 plus cosine. Combine your like terms on top. The cosines cancel. 1 plus 1 is 2. The bottom foils out to 1 minus cosine squared, which we know then becomes sine squared. And then 2 over sine squared becomes 2 cosecant squared. Again, I'm going to go through these fast because I don't want you to sit here and listen to 20 minutes of me explaining problems. So if that was way too fast for you, rewind it. 45, common denominator again. So then this, the left cosine of x, that numerator becomes this piece from here to there. Okay, and that's just from distributing. And then you're going to have to distribute again. Make sure you also distribute the minus sign. So minus cosine of x now becomes this from distribution there. Combining like terms gives you this new numerator, and foiling out the denominator gives you that denominator. From here to here, you're just using Pythagorean identity. And then because there's all multiplication on top, we can simplify, we can cancel. A cosine here leaves cosine to the first and a cosine there. And then lastly, we know that sine over cosine becomes tangent. 48, again, it's common denominator. Your new numerators are these. Cosine squared of x plus sine squared of x becomes 1. So that 1 plus 1 becomes 2. They factored out a 2, and then that allows you to cancel 1 plus sine x, and then the cosine in the denominator becomes secant. Okay, 49. Sine squared, they replaced it with what it's equivalent to by the Pythagorean identity, 1 minus cosine squared of y. Then they factored the numerator. Okay, that's why we practice factoring, because sometimes that's going to help you simplify. It's a difference of squares, factors into that, and then 1 minus cosine of y's can cancel. These are now those substitution problems, so all you have to do is take your original problem and substitute whatever it says in for x. Go ahead and distribute the square, factor out the 9. 1 minus cosine squared is sine squared, and then actually take the square root. And that kind of just continues. It's the same type of work over there for 57. 59, you are plugging 2 sine of theta in right there. So there it is. This one was a full equation. That's fine. You're still going to distribute your square. You're going to factor out the 4. You're going to turn 1 minus sine squared into cosine squared. So all of that was the same. We were just bringing down the right side. Then you can go ahead and take your square root. Again, still the same. And then finally, we're trying to keep going. So we solve for cosine by dividing by 2. And we're done there. We've found cosine of theta, which is what our problem asked us to do. It also asks us to find sine of theta, though. So to find sine of theta, They are using basically the Pythagorean identity solved out, but you don't have to do it that way. You can just use the original form of it. So sine squared of theta plus what's cosine squared? Well, that would be square the top would be 2, square the bottom would be 4. So then we would get sine squared of theta, subtract that, you're going to have 1/2. When does sine, oops, not ready yet, sorry, take the radical. So that would be 1 over radical 2, but then that's really radical 2 over 2. We got to put the plus or minus sign really here as well. So sine of theta equals plus or minus radical 2 over 2. Normally we would think about, oh, well, what quadrant are we in? And that would determine your positive or negative, but we have no idea what quadrant we're in. We don't have that information. So you can't solve for theta, but that's okay. We weren't asked to. We were asked to solve for sine and cosine, and we just did that. So 60, the beginning of it's really all that same stuff where you substitute in, distribute your square, multiply it by 4, factor out 16, replace 1 minus cosine squared with sine squared, take the square root, I am going to say, though, that I disagree that there should be a plus or minus sign here because we didn't introduce the square root into the problem. The square root was already there. So I don't see why that would be a plus or minus. I don't know. I don't see why that should be there. Then divide by 4. And then, again, they're doing, they've taken this Pythagorean identity and solved it for cosine and used that. You don't have to do that if you don't want. You can do it the same way we did it over here. But either way, you're going to end up with the same answer. All right, one more problem, 68. On this one, they went with the strategy of putting everything into sines and cosines. So secant becomes 1 over cosine. Tangent becomes sine over cosine, and you've still got your minus sign. Just to talk about the directions on this, the directions are different, but at the end of the day, they're just saying, take this original expression, and they want you to end up writing it as this expression. So this is kind of a preview of where we're going in 2.2, where they give us the beginning and the end. Okay, so how can you get this to be written as that? All right, so they wrote everything as sines and cosines. Go ahead and multiply these together. You would then get this. And then they did a common denominator. So we still have that sine of x in the numerator, but this would then have to be multiplied by cosine squared. Factor out a sine. 1 minus cosine squared is equal to sine squared. And then we can do, this is not a heart problem, there's no plus sign. We're just going to bring our sign down, and we're going to write this portion of it as tangent of squared. Okay, because we really could have written this fraction this way. We can pull this piece off because if you multiply this together, you're still going to have this. So you got to kind of keep that plus and minus and multiply all separate. All right, that's the 2.1 end of that homework.